Greetings, everyone. Lars here. Excuse me. Need some coffee. It is June 14th at 11:15 at night. But before the vampire goes to bed, I must do a Python video for you guys because I want you to have it. The unit ends Saturday already. Summer goes fast. Summer goes really fast. And it's fun. We're finally at the point now. You have Unit 1 under your belt. Data, if then, simple arithmetic, different data types, things along those lines. Now you've added two really powerful things. One, strings and lists. You have sequences. You can store things. You can, put things somewhere where you can use them. And the second part, the real important part, is looping. Now you can navigate over that data. Now you can do different things with that data. So now you're at the point where you have enough things in your toolbox that we can actually start solving real problems. And that's what we're going to do tonight. I'm going to take you over to a site called Project Euler. And basically the history behind this whole process is that 7 years ago, one of the things I did at Rutgers was I created a collaborative computer lab. Different from a regular computer lab where you go in and there's 20, 30 computers and they're all facing forward and blah, 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 boring. We wanted to create a collaborative lab where it was more about collaboration, and we provided wireless and a lot of power, and kids would bring their own gear and they would hang out and they would have meetings and they would work on projects together. And yeah, I've already told you the spiel, I think, in class 1 about, third spaces and collaborative spaces and things like that. So first couple of years, we're running the cave. I have tutors in there. I'm in there managing the space. And students would come in and say, hey, what should I do if I want to learn Python? And at the time, there isn't a Python course to take. Now we have a Python course in Camden. There's my course on Bush for New Brunswick people or Piscataway people to take. But back in the day, there were no Python courses. So what we would tell our students is this, and you know this because you're doing the midterm assignment, we would send them to learn Python the hard way. And we would say, go through all of the chapters of Learn Python the Hard Way, do what it tells you, and don't cut and paste. But actually type up all that code and get it running and learn the rudiments that way. Then, once you've done that for practice, go start solving Project Euler problems. And this, I'm going to go there right now, is Project Euler. Project Euler is a site that has about, well, let's see how many archives. That has... Oh, they're not at 600 yet. 597 number theory problems that lend themselves to being solved with computer programming languages. So a lot of people will solve these problems with C++. Some people will use just C. Some people will use Java. But a lot of people, probably second most popular, maybe even the most popular at this point, use Python and actually go to Project Euler to get these problems. Now, you can see the problems are listed, and all you have to do is go click on them, and multiples of 3 and 5, you might have seen that before. And you can say, like, largest prime factor. The prime factors of 13, 1, 9, 5 are 5, 7, 13, and 29. What is the largest prime factor? The number, boom, boom, boom. They're number theory kinds of problems, but you need programming to solve them, okay? Some are easy. Some are insanely hard and get crazy. You can register for free, doesn't cost any money, and get your own ID and keep track of the problems you solve. So what we would do is we would tell students, go do Python the hard way. Then go to Project Euler, get yourself an ID, and solve the first 50 problems. And if you solve the first 50 problems using Python, then you pretty much have your chops. You know what you're doing. Then we all learn programming languages for a reason. Then you could probably go do that reason. Go get that job. Go work on that project you want to build. Go do that website you want to build, That's I digress as usual, but that's usually a big problem with computer programming is that people want the hand-holding to go on forever. And they're like, what's the next book I should do? What's the next class I should take? It's like, no, crap. Go do it. Go do it. At some point, you got to knock it off and go do it, okay? You're not there yet. Don't think you're there yet. We'll get you there. We're getting you there. So what I usually do, and I also bring up the point that it's not a very good idea because I'll tell you not to advertise solutions to Euler problems because you want people who come here brand new to have a chance to solve things for themselves. That said, probably the first 100 are on Stack Overflow. So if you Google, Euler 23 Python, you'll get a Stack Overflow thing that shows you the answer. Don't go get the answer. Don't cheat. Go ahead and do it. Plus, the one we're going to do, you're going to see this, is insanely simple. So, and then at the end, what I'll do is I'll log in because I'll show you I created a user ID for our class. So all of you guys, if you want, can solve any of the Euler problems and actually log in as our class, solve it, and it'll be saved. I'll show you how that happens later when we solve the thing. But for now, I'm going to look at number 6. And what number 6 says is the sum of squares of the first 10 natural numbers is, and blah, 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 you see it done, 385. The square of the sum of the first 10 natural numbers is 1 plus 2 plus 3, blah, blah, blah. Squared is 55. Squared is 3,025, okay? Hence, the difference between the two is 2640. Now, we have a worked example, solved problem there for 10. Now, find the difference of the sum of squares of the first 100 numbers, okay? So, kind of lends itself to programming, right? We can use a variable or just use a certain, data item there. And we can first do it with 10 to test to see if our algorithm works right. And then after that, we'll just take the 10 and make it 100, and we should be okay, right? All right. So let's do that. You know what? We're going to start from scratch. I'm going to fire up idle. Only 3.4 still. My lazy butt has not. Well, I'm running 3.5 with my spider, but that is for another time. New. All right. I'm just going to say Euler 6. Large, keep it simple. And the first thing I'm going to do is I'm going to make a code block. And when I solve Euler problems, or I solve problems like this, just highlight the question. Hit copy. Minimize that. Punch it in there. That doesn't look very good. So let's make it look nicer. There we go. Now that's 1 squared, 2 squared, blah, blah, blah. So it looks a little hinky, but we know what the deal is because we just read it. That should say first. All right. So we have it right there. The sum of the squares of the first 10 natural numbers is that. The square of the sum is the first thing that, blah, blah, blah. Hence the difference between All right. We are in good shape. Oh, actually, let me save. We're not in good shape. Let me save. So let's go to Python, data science. That's what we're doing. And summer. Unit 2. And I'll call it Euler. It's pronounced Euler. All right. Euler 6. I made that mistake in front of a big old math class and got made fun of. Took all my self-esteem and threw it out the window. Because I said Euler, and I still say Euler. To this day, I'll still say Euler. Because this is what it looks like. Looks like Euler. It doesn't look like Euler. It is, though. All right. So, we got a problem to solve. And if you look up there, we don't really have a problem to solve. We've got 3 problems to solve. First thing we want to do is find the sum of the squares. The second thing we want to do is find the square of the sum. Then the third thing we want to do is find the difference of those 2 numbers. So, first thing I'm going to do, I think, is sum of the squares. All right. So, how am I going to do that? I'm going to create a variable called SOSQ for sum of square. I'm going to set it equal to 0, right? And then what do I want to do? For I in range. Do I want to start with 0? No, because it does me no good. 1, comma, 11. First thing I don't want, because I'm going to 10. For that range, I now have 1 through 10 as I go through my loop. So what do I want? I want the sum of the squares. So I'm going to make SOSQ equal SOSQ. So I keep adding along the way. I, bang, bang, 2. Right? Print. Sum of squares is SOSQ. So if I run this, the sum of the squares is 385. And if I look up here, I see that is correct. Too many spaces there. My OCD will not let that stand. So we've got the first part done. We now have the sum of the squares is 385. So we are in pretty good shape. Now, the magic of cutting and pasting is going to allow us to just say copy and then paste. And then what I'm going to do is I'm going to say square of the sum. And I'm going to make this variable now SQOS because it's the square of the sum equals 0. We don't need that extra line in there. The OCD's are really kicking in. For I in range 1 to don't forget to change the variable here. Square of the sum. And we don't no longer want to square that. We want to legitimately just sum everything up. Okay? And then when we jump out of the loop, because we've gotten the sum by doing our little counter there, we're going to go square of the sum equals square of the sum squared. And that's going to give us our good answer. Okay? I hope. I sure do hope. Help if I change that variable to make it correct. So this is no longer correct. Square of the sum, might as well capital, sum of the squares is. So now I run, dun 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 dun, sum of the squares is 385. Square of the sum is 3025. I look up here and I see with our worked examples that is correct. So I've solved the first two problems. I've got one more left. And this shouldn't be so bad because I have them saved in variables now. Find the difference between the sum of the squares of the first 100 and the square of the sum. So we'll come down here and I will say print the difference is, comma, and then I will just say square of sum minus, I'm doing something wrong, sum of square, and that should be fine. I'm missing a thing right there, and that should give me, what is it, 2640? Yes, 2640 right there. Okay, get rid of that space. Look at that. Sum of the squares is 385. Square of the sum is 3025, and the difference is 2640. That matches the results we have up there in our worked example. So I've got a little piece of code here that's working out that problem for me. Pretty snazzy. But we're not there yet, because the real question is find the difference between the sum of the squares of the first 100 natural numbers. So what do we do for that? That's a little weird. 2 spots. And we're going to go back and change it so we only have to do 1 spot. You ready? Take that 11, make it 101. Take that 11, make it 101. That's the magic of programming. We've now taken that range from 1 to 10. We've made it a range from 1 to 100. So we're going to loop 100 times instead of 10. And we're going to keep track of all those squares. And then we're going to sum things up and square that one big number. And then when I run this program, I get new numbers. So at the end, the difference is 251, 641, 50. Okay? I'm going to do one more thing because I'm crazy that way. What if I only want to change it in 1 spot? I'm going to create a variable called limit. I'm going to make it 10. I'm going to come down here to the end of my range. I'm going to say limit. I'm going to come down here to the end of my range. I'm going to say limit. And then I'm going to run it. And everything's going to be good, right? All right. No, it won't. Why? Because we want limit. If I left things like that, limit would be the first thing I don't want. So I would only get from 1 to 9 when my limit is 10. What I really want to do, if I want to make this work in a Python world, is I just want to do a little cheat and add 1 to it. Okay? So now when I do 10, my range will be 1 to 11. Okay? 1 to 11. If I do 100, my range will be 1 to 101. 1 to 101. And it'll give me the first thing I don't want. Let's rerun for that 10. And you can see we're back in business. We've done it with our 10. And then if you come here and make that 100, save, go, we're back in business. Now, We wrote a nifty little program here. Look, it's not a lot of code there. 2 loops, okay? Do a little simple arithmetic with our answers that we get. We're solving real problems now, okay? But did we solve it? I don't know. We got to go figure that out. So I'm gonna freak out. There, I am going to copy that answer so that I have it in the clipboard, and I'm going to go back to Project Euler. But what I'm going to do is I'm going to sign in. What I'm going to do, oh, see, I'm not going to sign in as me because I got a whole bunch of answers in there, and you don't need to see all that mess. What did I call it? PMDS dash SU 2017, SU for summer. So that would be the user ID, and the password is Python class, capital P, Y-T-H-O-N, capital C-L-A-S-S. And then you have to put in the confirmation code to prove that you are not a bot. Okay? And then click sign in. Woo, look at that. Sign in successful. So we are signed in as PMDS-SU 2017. I have answered no questions. And if we look at progress, you'll see that because I haven't done a damn thing. Okay? We are tabula rasa. We are empty. 0. I'm going to go to archives. And I'm going to go to sum square difference. And you can see that I'm logged in now as a user. So I'm given a spot for the answer. I'm going to paste the answer in there. Okay? And I'm going to give it a confirmation code. 11665. Okay? And then I'm going to click check. And when I click check, it's going to see if my answer is correct. And then one of the best buzzes in beginning programming is when you hit click check, if you're correct, you get a big green check mark. And when you see that big green check mark, you're like, yeah. That's a very nice little buzz when you get that green check mark. Let's see if we get it. Check. Took forever. Dun, 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 dun. And as you can see, I get my big green check mark. Okay? And we are the 357,000th blah, blah, blah person to have solved the problem. Now, if I go here and I look at progress, you can see I've solved number 6. And it'll tell me the answer. And it'll tell you how many people have solved it, the difficulty rating, which is very high, and some other things like that. And then you can look down here to different solving awards. If you do all of the, you can do easy as pi for all the pi numbers. You can do prime obsession for all the primes. You can do a whole bunch of things. Okay. You can also go to statistics and look up who has solved what problems. I mean, there's a lot of people who have just solved the first couple of problems. But if you come down here to, what is it? We used to tell people to do the first 50. And right now, back in the day, it used to be 5%. Now it's more like 6%. But back in the day, the first 50 problems would make you in the top 5% of people who use the site, which we thought was pretty good. Now, if you want to be in the top 5%, you have to tackle 55. So it's not that much different right now. So you can get stats about all the different problems and what they're about. You can chart your progress. As you can see, we solved 6. So Project Euler is great. Project Euler, some of the problems are wonderful. It's not just knowing the math and having to look up number theory things and having to learn about primes and having to learn different things like that. There's some of that. But it's also how to navigate through your data, how to navigate diagonally through data, how to do different number problems that way. It's a really, really clever site. So you don't only have to use this class thing. Go set yourself up with a user ID and start doing problems. Then you'll say, oh, you want to be a centurion, so you do 100 of them, and you can do A, B, and C. We actually, in the computer science department, had an entire club start up around this. It was called Project Euler. Well, it was called just Euler. And they would solve problems. They would come and meet weekly and just solve problems. And it actually morphed into an interview prep club where now they got this book called Cracking the Code, and they sit and they work on code, on whiteboard interview problems, and it's really great. So I can't say enough about Project Euler. It's really cool, but the whole point of this exercise, and I'm going to end soon. I'm looking at the clock. I know I've gone about 20, 25 minutes. The whole point of this exercise is that you can solve problems now. You have iteration. You have variables. You have, if then, you have a lot of things in your programming toolbox now that allows you to tackle some non-trivial problems. So realize that. Tinker around. Play with different things. You're going to be in even better shape after Unit 3 when I teach you about libraries and functions and modularity and all of that stuff. Don't worry about that for now. Okay? Project Euler, really cool. So, see this code right here? I am not going to put it on Sakai for you. You code it up yourself, which is real hard, right? Freeze this video right here and look at the code and understand it, and then just go type it in. I mean, it's not that long. 26 lines with a boatload of comments in here. It's not bad at all. All right. So I'm not going to put this online. You go puzzle it out, and you go solve it, and you go figure it out. But we can start to solve some problems now. And you also, can learn some programming tips along the way, like using a variable to do the end of your limit. And then I can, by just changing a single space, I now have gone from 100 to 10, and then I can go back to 100 if I wanted to. I could do 1,000, and I would still be good. Okay? All right, then I'm going to get out of here. You be good. As far as announcements are concerned, there's only two announcements I'm going to give you. One, I don't like the fact that the quiz was on a Saturday. I like my weekends in the summer just like everybody else. So this is what I did. I opened it up at 7 a.m. on Friday morning. So from 7 a.m. Friday up until 3 a.m. on Sunday, you have to do the quiz. So you have more than 2 days or about 2 days to do this stupid quiz. Okay? That way, if you're going away for the weekend, give yourself an hour or however long it takes on Friday and get it done. If you're not going away for the weekend and you like to take that time on Saturday to do a little bit of Python, you're in great shape. It'll be open all day on Saturday. All right? Well, I gave you some extra time for the quiz because I don't like, being forced to do something on a weekend. Not a good thing. Okay? Now, the assignments are due Saturday night at midnight. That's easy. Code them tonight and put them online. Code them tomorrow and put them online. If you want to do them early, you could do that right now. The quiz, though, you don't have yet, so that's why I didn't think that was very fair. So I opened it up super early on Friday. All right? Then you take the quiz. You do the assignments. You make sure they're posted by Saturday. Make sure by the end of tomorrow you have your forum post up there. Okay? Tomorrow's the drop dead for the forum post. You get me a post on Friday, you're only getting 4 points for it. All right? And you see these little points will add up eventually. You'll be screaming and yelling come the end of the course. So get the low-hanging fruit. Get those posts in there. All right? I already know you guys aren't reading when you should be reading because I put a little Easter eggs in the slides and then little extra credit points. If you're not asking me for the extra credit point, that means you probably haven't read yet. Okay? Some people have. Some people are doing it when they're supposed to, and they're sending me these little things. So you don't have very much time. So I would get going. If you're listening to this tonight and you haven't, read over the slides or got to work on those assignments, I would get going. All right? All right, good. I'm sure you'll be fine. I don't mean to be a jerk about it. All right, then I'm getting out of here. You be good. Quiz on Friday and Saturday. Assignments due at the end of the day Saturday. And we're going to be good to go. Then Sunday, we're going to get started. I'm going to get you the slides on Unit 3. And Unit 3, you can breathe a little. There's a lot of work, but it's fun. And you can breathe a little because it's longer. It's not going to be this breakneck pace. If I'm not mistaken, Unit 3 will actually encompass the 4th of July holiday. So we're going to go for 2 or 3 weeks with that. So you got no worries, all right? All right, good. Then I'm getting out of here. You enjoy the weekend. And good luck with all this stuff. And go play with Project Euler. It's great. It's really great. All right? Good. Then I'll talk to you later. Bye.